Welcome to part 2 of the video series. Um, this part will deal with doing some text analysis on certain existing models which are available on the internet. So, as part of my project, I did not want to stop with basic visualizations. I wanted to do some text mining or apply some existing model on the review data to get some actionable insight which makes business sense. With that said, all the initial analysis or research work which I did pointed me towards something called as topic modeling using a method called LDA. So this is one of the papers which I glanced through, and they talk about LDA. LDA is classification algorithm which groups words of similar context. So the basic premise is that if we apply an LDA model, we'll be able to group similar words of similar context together and assign a topic to them, like for example a topic of room, a topic of staff, etc. And we can calculate the sentiment and check, alright, so this particular branch has negative reviews on this topic, on a topic of room, on a topic of staff, etc. Which obviously it provides more actionable insight than doing a normal word cloud. So this was another report, a government report from the United States, which again talks about using LDA for topic modeling consumer complaints. I searched on the internet for any existing code or any existing model which uses LDA, and I came across a code written by a professor in the UK called Laurie Williams. So this is her GitHub page. So she has done this topic modeling, or in this case it was called aspect based opinion mining. Instead of topics, they call this as aspects. Anyways, what she has done is to give a basic outline of what she's done, what the model does. We collect the reviews and we clean the data, or we pre-process it, removing the punctuation and converting it all to lowercase, and then using a module in Python called Vader Sentiment. It has a function called Sentiment Intensity Analyzer. So we populate a sentiment score, and so hence what is the sentiment of a particular statement. Once we do that, we take the clean statement and tokenize the statement into words. We remove stop words from it, and then we limitize all the words, and we apply a count vectorizer on it. So the count vectorizer is going to perform a count of all the words present, and the output of count vectorizer is going to be given to the LDA model is going to be applied on the count vectorizer output. We have the option of giving how many topics we want the words to get categorized into. So in this case she has given 5 topics, and we can see that each statement is assigned a score based on which topic it relates to. So we see that for the first statement it relates more to topic 5, second statement relates more to topic 1. So this is mentioned in the dominant topic column, and so this procedure continues, and the code also assigns a topic name to the topics. So in her case, she took the customer reviews of a mobile phone, and those topics made sense. But when I ran the same code, when I modified it to fit my data, and I ran the same code, the topics were not well segregated. They were not clear. There were a lot of words under each topic, and the correlation between words within a topic did not make much sense. So this model, I was really not happy with the output of this model. For example, you can see pillows and postcode together in the same topic. You can see food and generator. So the segregation into different topics was not really robust. What I did next was I searched if there was a way we could train an LDA model by giving it some inputs, and then based on the inputs we've given, we can parse the entire text data and get it classified better. So that led me to something called as guided LDA, which is again a Python implementation. So it's a code written on top of the existing LDA model. So for providing the test data, I focused on this paper which had already classified a few topics on restaurant reviews. So I passed them in as the training data for the guided LDA model. The guided LDA model website had an example of how to write a code for applying the guided LDA model. So this is the GitHub website for the guided LDA documentation, and they have given a clear-cut example of how we can apply the guided LDA model by giving it the training data. So again, I modified their code to fit my data and using the training data we had. Again, once the code was run, the results were not very satisfactory. You can see that room appears both in topic 1 and in topic 2. So again, the segregation was not really good in this case as well. So I searched again for a different paper and a different implementation, and I came across one paper where they have done topic extraction or aspect extraction based on POS or parts of speech tags and dependency parsing. So part of speech is nothing but noun, verbs, etc., and dependency parsing says what's the subject, what's an adjectival modifier, what's the direct object, etc. So there was a medium. There was an article in the Medium website written by a person called Rohan. So he had implemented this very research paper using Stanford NLP parser. So this was naturally my next step to modify this existing code or model to fit my data. So I did modify the code, and I did run the model on this, but what I found was the output was very messy, in the sense even though they had you filtered out by parts of speech tags and by dependency parsing, somehow this existing model did not go well with the review text data which we had. And this was a very complex code with a lot of loops and conditional statements. So it took a lot of time to execute. So we will look at the output of this model, why it didn't fit well, and also we will look at the model which was developed using Spatie parser.